You are orbiting something that never sleeps. Right now, without feeling a thing, you're being flung around the center of the Milky Way at 230 kilometers a second. Your whole life, your parents' lives, every ancestor you ever had, dragged in the same slow circle around the same invisible point. And that point has never once gone quiet. You've been told what sits down there: a roaring monster, a drain that swallows stars and waits to wake up and eat the galaxy whole. Good story, almost entirely wrong. It has a name: Sagittarius A star, the supermassive black hole at the heart of our galaxy. And in early June of 2026, a team pointed the best telescopes on Earth at that spot and caught it doing the one thing a monster is not supposed to do: breathing. Every channel is shouting the same headline. The monster is stirring. It's waking up. It might not even be a black hole. Here's the thing. The truth is stranger than the panic, and quieter. The most feared object in our sky is also one of the most starved giants we have ever found. 4 million suns of gravity, and it can barely feed itself. Once you see why, the fear turns into something closer to awe. It sits about 26,000 light years from your chair. Too far to have ever been a danger to you. And as far as physics can see, too far for every tomorrow. That's the paradox. Something 4 million times the mass of the sun, close enough to swing your entire planet around it, starving on scraps. Both of those are true at the same time. Making sense of that contradiction is the whole ride. By the end of this, you'll understand 3 things. How we know a supermassive black hole is even there, when no human has ever seen it directly. What that June breathing was exactly, and why it took 50 years to catch. And the question sitting under all of it: could Sagittarius A star ever threaten Earth? If the deep dark is where your head goes quiet, subscribe and stay to the end. And hold on to one thing before we go anywhere. About 3.5 million years ago, this same silent, starving giant did something so violent that our ancestors, standing on the plains of Africa, could have looked up and watched it burn in the night sky. We come back to that near the end. It decides whether we are safe, and the answer is not the one the thumbnails want you to believe. Start with that motion, because it never quite leaves you. Our sun does not sit still in space. It falls around Sagittarius A star on a vast orbit, one lap every 230 million years or so. The last time the sun completed this circuit, the very first dinosaurs were only just appearing on Earth. And because the whole galaxy drifts as we circle, your true path through space is not a circle at all. It's a corkscrew, a slow, endless spiral, with you riding the outside of it, held on by the pull of something you will never see. So the first real problem is easy to say and brutal to solve. How do you find a thing that gives off no light, buried behind gas and dust so thick that ordinary telescopes go blind long before they reach the center? For most of the 20th century, 2 camps fought over what sat down there. One side said a giant black hole. The other said no. Maybe a dense swarm of dead stars, something far less extreme. Nobody could prove it either way. The evidence was hidden under 30,000 light years of murk. Then, in the 1990s, 2 teams tried something patient and a little insane. André Ghez in California, Reinhard Genzel in Germany, both working in infrared light that can slip through the dust where visible light drowns. Night after night, year after year, they tracked individual stars near the galactic center and watched them move. Not drift, move. Whole stars swinging around some unseen mass on tight, fast loops. And one star handed them the answer. They call it S2. It orbits Sagittarius A star on a long, stretched loop, and one full lap takes about 16 years. Think about that as a job. You could spend an entire career watching a single star go around one time. And at its closest pass, S2 is not strolling. It is screaming along at nearly 3% of the speed of light, 7,600 kilometers a second, fast enough to lap the whole Earth in about 5 seconds. Nothing but a monstrous compact mass can whip a star to a speed like that. Run that orbit through the math, and one number falls out. 4 million times the mass of our Sun, crushed into a region smaller than our solar system. You cannot do that with a swarm of dead stars. The dance of ES2 was the fingerprint, and it pointed at exactly one kind of object. In 2020, Ghez and Gensel shared the Nobel Prize in Physics for it. Proof, written in the path of a single star, that a supermassive black hole does sit at the center of the Milky Way. The old argument was over. The stranger one was starting. For all of that, no one had ever seen it. A black hole gives nothing back. No light, no signal, no reflection. There is nothing to photograph except the one thing it cannot hide: its shadow. Pile enough superheated gas around a black hole and the gas glows white hot, and the darkness at the center bites a perfect round hole out of that glow. The silhouette of the point of no return. Catch the glow, and you catch the outline of the dark. On the 12th of May, 2022, a network of radio dishes spread across the whole planet. The Event Horizon Telescope showed us that bite for the first time. 8 observatories from Hawaii to the South Pole, all staring at the same spot on the same nights, linked into a single telescope as wide as the Earth. They gathered so much data it had to be flown around the world on stacks of hard drives, because no connection could carry it. Then came years of careful work to turn all of it into one picture. And what came out was a glowing ring wrapped around a black center. That was Sagittarius A star, its shadow printed in radio light. To catch something so small and so far, the astronomers said it was like standing on Earth and reading a donut sitting on the surface of the moon. But Sagittarius A star fought them the whole way. Its gas whips around so fast that the whole picture changes in minutes, like trying to photograph a puppy that will not sit still. When the blur finally cleared, the shadow matched the prediction almost exactly. The thing S2 had traced by its orbit now had a face. Now let's talk size, because the numbers do something strange to your head. That shadow marks the event horizon, the boundary where nothing, not light, not information, ever comes back out. For Sagittarius A star, that boundary runs about 24 million kilometers across. Its radius, the true edge, sits near 12 million. Sounds enormous until you place it. Drop Sagittarius A star where the Sun is, and the entire point of no return would fit inside the orbit of Mercury. 4 million suns, folded into a ball you could tuck inside our innermost planet, casting a shadow you could read from the moon. And this is the moment to feel that distance, not read it. The light from Sagittarius A star takes about 26,000 years to reach us. So the glow in that famous picture did not leave the black hole recently. It set out while the last Neanderthals were still walking the earth, before farming, before writing, before the first city was ever built. Every time you look toward the galactic center, you're staring 26,000 years into the past. The black hole in the headlines is a photograph of a moment that ended before human history began. Here is where the sleeping monster story falls apart. In 2023 and 2024, the James Webb Telescope locked onto Sagittarius A star for about 48 hours straight. It went looking for a slow, moody giant. It found the opposite. The black hole was flickering the entire time. Never dark, never still. 5 to 6 big flares a day with smaller flares crackling in between around the clock, following no schedule anyone could pin down. So what is a flare down there? Picture a thin, blazing disk of gas circling the black hole, packed and hot and never smooth. Knots form. Magnetic fields tangle and snap. A blob of gas gets superheated and whipped around the edge, and for a few minutes it screams brighter than everything around it, then fades, and another takes its place. The astronomer who led the study, Farhad Youssef Zadech at Northwestern, put it plainly. "It is always bubbling with activity," he said, "and never seems to reach a steady state." Here is the part that gets under my skin. 5 to 6 flares a day means roughly 1 every few hours. So somewhere in the time it has taken you to watch this far, Sagittarius A star has flared at least once, a burst of gas hotter than the surface of the sun, 26,000 light-years away, that no one on Earth felt, and no one will feel for another 26,000 years. It has been doing that on and on since long before you were born. So if it has never once slept, why does everyone keep insisting it woke up? Because active and waking up are not the same thing, and this is where almost everyone gets it wrong. All that flickering is real, but it comes from a starving animal, not a feasting one. The giant black holes at the hearts of other galaxies blaze with the light of entire quasars, outshining every star around them combined. Next to those, Sagittarius A star is faint, whisper faint. It is one of the most underfed supermassive black holes we have ever studied. It is not devouring the galaxy. It's licking crumbs off the floor. How little does it eat? Picture a giant seated at a banquet the size of a galaxy, taking 1 grain of rice a year. Most of the gas that falls towards Sagittarius A star never makes it in. It gets flung back out, blown away, or misses the mouth entirely. The black hole is enormous and its appetite is tiny, and that mismatch is the real character of the thing. It is not a predator on the hunt. It is an old, slow giant, mostly ignoring a feast it can't be bothered to finish, and we watched it fail to eat, live, in real time. In 2014, a clump of gas called G2 came swinging in on a path that grazed the black hole, and astronomers braced for a feeding frenzy. Telescopes on every continent locked on. The gas would be shredded, they thought, and Sagittarius A star would flare up as it swallowed a real meal. It didn't. G2 stretched, wobbled, and sailed right back out, mostly in one piece. The monster barely took a bite. That was the moment it became clear how little this giant eats. So what exactly did they catch it doing in June? This is the headline that set off all the noise. In early June of 2026, a team at Northwestern, using the ALMA array high in the Chilean desert, together with NASA's Chuan-Dra X-ray Observatory, announced they had finally caught Sagittarius A star breathing. Not roaring, breathing. They found a cone of cold molecular gas near the black hole, opened at about 45 degrees, that had been scooped hollow from the inside, carved out by a faint, steady wind flowing off the black hole itself. That cone is the whole point. A black hole this quiet should barely disturb the gas around it. And yet here was a clean, hollow scoop in the cold gas, exactly the shape a slow wind would carve if it had been blowing outward for ages. Not gas falling in. Gas being gently pushed away. The imprint of an exhale, frozen into a cloud. For the first time, we were not guessing at the breath from theory alone. We were looking straight at the shape it leaves behind. And here is the part the panic skips entirely. This wind was not a shock. It was a debt, 50 years overdue. Mark Gorski, who led the work, framed it this way. Unless a black hole sits in a perfect vacuum, it has to blow a wind somehow. And this was the first time anyone had a clean enough view to see that wind's imprint. It is what astronomers had been hunting for roughly half a century. Not a monster waking up. A prediction finally showing its face after 50 years of hiding. His colleague Lena Murchikova added the detail that kills the scare story outright. The wind, she said, is not powerful, and its direction probably wanders over time. This gentle outflow has likely been blowing for at least 20,000 years. It started before the last ice age even reached its peak. So read the June news again, slowly. Sagittarius A star did not start breathing this summer. We only learned how to see it breathe. The event was not out there in space. The event was us, finally able to look. Let's answer the question straight and sort the noise from the science. Is Sagittarius A star waking up? No. The flares have always been there. The wind has blown for 20,000 years. Nothing in the June data shows a giant stirring from sleep. It shows a quiet one, photographed mid-breath for the first time in human history. Every honest read of the numbers points the same direction, away from the monster and towards something far more interesting. There is a louder claim making the rounds, that Sagittarius A star might not be a black hole at all, but something stranger, a boson star or a gravastar, wearing a black hole's mask. It makes a gripping headline. The problem is the evidence. The event horizon image, the orbit of ES2, and a tiny twist in that orbit called Schwarzschild precession, the slow turning of the star's path that Einstein's gravity predicts, measured to the letter in 2020. All point to one answer and only one. It's a black hole. The exotic alternatives are a fringe idea most physicists set aside. But before we ask whether it could hurt us, you need to see how small our giant is. We keep calling Sagittarius A star a monster. On the scale of the universe, it's a house cat. 4 million solar masses sounds unthinkable until you meet the real giants. The black hole at the center of the galaxy, M87, the first one ever photographed, is more than 1,000 times heavier than ours. And far out in the distant universe sits Ton 618, a black hole of roughly 66 billion suns. That is about 16,500 times the mass of Sagittarius A star. Next to Ton 618, the terror at the center of the Milky Way is a rounding error. And yet, when the Event Horizon Telescope set its picture of Sagittarius A star beside its picture of M87, a black hole 1,000 times more massive, in a whole other galaxy, the two shadows look strikingly alike. Same round dark, same glowing ring, a factor of 1,000 apart in mass, and near twins to the eye. That is not a coincidence. It's a clue to how simple these things are underneath. A black hole keeps almost no memory of what fell in. Not the color, not the chemistry, none of it. Mass, spin, and little else. Whole galaxies of matter boiled down to a shadow and a ring. So what would happen to you if you fell toward one? Not the horror you're picturing. Something quieter and worse. As you dropped feet first toward Sagittarius A star, gravity would pull your feet harder than your head, because your feet would be closer. That difference would stretch you, longer and thinner and longer still, cell pulled from cell, until you were drawn out into a single thread of atoms trailing into the dark. Astronomers have a name for it that is far too gentle. Spaghettification. You would not fall into a supermassive black hole. You would be poured into it, and no signal you sent would ever climb back out to tell anyone what you saw. Here is the loop from the opening, and the real answer to whether this thing has ever been dangerous. Roughly 3.5 million years ago, Sagittarius A star was not licking crumbs. Something fell in, a lot of something, and the quiet giant flared into a full beacon, what astronomers call a Seyfert flare. Two colossal bubbles of superheated gas blasted straight out of the galactic center, one above the disk, one below. We can still see them today. We call them the Fermi bubbles. For years, those bubbles were a mystery of their own. NASA's Fermi telescope found them glowing in gamma rays in 2010, arching high above and below the galaxy. And no one was sure what had blown them. Then the pieces fit. Each bubble reaches about 30,000 light-years out from the center. Together, they span close to a third of the entire Milky Way. That is the scar left by one eruption at the core, and the sheer size of it tells you how hard our quiet giant once hit, and the same flash reached even further than that. Andrew Fox and Joss Bland Hawthorne traced its fingerprint across 200,000 light-years of space, out to the Magellanic Stream, a vast ribbon of gas trailing our neighbor galaxies. They read it in the light of 21 distant quasars shining through that gas, each one marked by the ancient blast. Fox said the flash lit up the stream like a Christmas tree, a cataclysmic event printed on the sky and still faintly glowing millions of years after it went dark. Now put a date on it. 3.5 million years ago, our ancestors were already walking upright on the grasslands of East Africa. On the right night, facing the heart of the galaxy, they could have seen a strange glow burning where the Milky Way runs thickest. The light of Sagittarius A star in full eruption. No one wrote it down. No one understood what they were looking at. But a human-like eye may have looked up and watched our galaxy's black hole roar. And here we are, millions of years later, still turning around it. So it has roared before. Which forces the real question, the one hiding behind every scary thumbnail. If Sagittarius A star erupted again tomorrow, are we in danger? Here is the honest answer, and it is better than the fear. We sit about 26 to 27,000 light-years from the galactic center. That single distance is the whole story. It is why the flares you're watching left the black hole while our distant cousins still walk the Earth. And it is why that ancient eruption, violent enough to scar a third of the galaxy, never touched life down here. That is the strange comfort in the number that started this video. 26,000 light-years is a wall of space so wide that even a full eruption arrives here as little more than a whisper. Our ancestors lived through the last one. The fossil record shows no mass extinction lining up with that blast. It happened, it was catastrophic near the center, and at our safe remove, life on Earth carried on without a scratch. Could Sagittarius A star flare again? Almost certainly one distant day. Could it reach us? By everything we understand about that distance, no. Not now and not for as far ahead as physics lets us look. The monster in the headline is real. The threat is not, and that is the part I find hardest to hold in my head. Not the danger, the indifference. Sagittarius A star has been flaring every few hours for longer than there have been humans to notice a sky. It has been exhaling a slow, wandering wind since before the last ice age, and it will keep exhaling long after the last person forgets it is there. We built a planet-sized telescope, won a Nobel Prize, and traced its breath back through 50 years of theory. And in all that time, it has never once known that we exist. There is still so much we cannot answer. We don't know exactly what lights those 5 or 6 flares a day. We don't know where the wind will wander next, or why this giant stays so hungry when others of its kind blaze like quasars. And we don't know what waits past that edge, where our physics stops writing sentences and the math goes quiet. Maybe that is the real reason we keep staring at it. Not because it might wake up, because it never had to notice us to run our entire sky. So here is where I'll leave you. You will spend your whole life circling a fire you will never feel, that will never notice you. and that was old before your species had a name. That's not a threat. It's the most honest thing the universe will ever tell you about your size. You are orbiting something that never sleeps. And tonight, while you close your eyes, it will not. That's as far as this one goes, but the edge always moves. This is a philo. Subscribe, drop a like if it earned it, and your next one's on screen now. I'll meet you a little further out.